This is video 11.4.2, and the goal here is to find the derivative of a function at a given point in time. So we're now using that catchphrase, that major word during calculus, derivative. So the first thing we need to know is what is a derivative. The derivative, first of all, we denote it with the f prime of x, as you'll see here. And that's how we read it, f prime of x, or we could read it as the derivative of f at x. And it's this formula that we talked about when we were talking about finding the slope of the tangent line. The derivative is the slope of the tangent line at a particular point in time, or a particular point along your function. So this is the general formula, but what's great is we're actually going to find the derivative of the function, so we have a description of what the instantaneous velocity would be at any point x. So if we go back to some of those problems we thought about when we had things like the firework problem, and we're thinking about, okay, how fast is that firework traveling? Well, I don't want to have to keep finding these limits over and over again. So you're going to see in this example how to find the limit one time so you can describe the slopes of all those lines at any point in time. So let's get started. Here's the function. F of x equals 3x squared minus x minus 2. And we're going to find the derivative, and then we're going to use it to find the slope of the function at 3 and negative 3. So let's take a look at the formula again, and let's use the formula to find the derivative. So the formula that was in this yellow box is f prime of x. The derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So I don't even have an x to plug in. That's where this is very different. So I'm going to take and plug in x plus h into my function, and then this function is actually the same as this, because that's f of x right there. So I've got 1/2 done. The box is good, but I have to find f of x plus h. So I'm going to do that work off to the side here and find f of x plus h by plugging x plus h in for the function, in for the x value. And I'm going to plug it in and carefully work it out. Okay, so it looks like I'm going to have 3x squared plus 2hx plus h squared. Let's see. Minus x minus h minus 2. Because that negative 1, of course, transferred to each of those. So let's see. This will be 3x squared plus 2hx plus h squared minus x minus h minus 2. I don't think I can simplify any further. So that is, in fact, the f of x plus h. So that's this value right here that I'm going to replace in my formula. So I have my f of x plus h is this. So I'm going to find the limit as h approaches 0, as h approaches 0 of, let's see, so 3x squared plus 2hx plus h squared minus x minus h minus 2. And then I'm going to minus f of x. I'm going to minus this whole thing. That's what f of x is. So let's put that in parentheses just to make sure I don't make mistakes. All over h. So let's see what happens here. Again, magic's going to unfold. 3x's will cancel. Let's see, what else will cancel? Oh, we're subtracting a negative x. So when I do that, it really will cancel with this negative x. And again, this negative 2 will cancel with this negative 2 because it's being subtracted. So all that green, all the f of x kind of disappeared with some of the f of x plus h. So let's see what we have left. So this is gone, this is gone, and this is gone. So we have 2hx plus h squared minus h all over h. Okay, and that's still the limit as h goes to 0. And continue with the process we've been doing. I want to get rid of the h, so let's factor it out. So we have the limit as h goes to 0 of h times 2x plus h minus 1 all over h. So this h cancels, and now I'm at the point where I can plug in 0 for h. So I have 2x plus 0 minus 1, or 2x minus 1. So this is a very different answer than what we've gotten. But what we have here is this is a description of all the slopes. Remember what a derivative is. It's the slopes of all x's for every single x on my quadratic. Every single x will have this slope if I plug in x. So that's good, brings me to the next question. So we've answered question A. That is the derivative. F prime of x equals 2x minus 1. Now, the good news is I can use this formula now because this describes every slope that I could ever want for every part of my function. So now I can use the formula for question B. B is asking the slope at 3. Well, all I have to do is use my derivative formula and plug in 3 because the derivative formula describes the slopes at every point. And so it looks like I'm going to get 5. So the answer is 5. The slope is 5 at 3 for this function. So it couldn't hurt, again, to look at the graph and say, is the slope in fact 5? Is it increasing and pretty fast? 5 is a pretty fast slope. And I should see that it's increasing quickly. Now, if I want to find at negative 3, now I'm going to put negative 3 in. Negative 3 minus 1, and I get negative 7. So that tells me the slope is negative 7. So again, if I look at the graph of this function, I should see a decreasing function that's decreasing quickly at negative 3. So these are my two solutions. So what we have to internalize is the fact that the derivative is a description of the slope at any point x. Because I didn't plug any numbers in at the beginning here when I did all of my limit work. So I'm talking about all of this work down here from here below. And what I started with here, I never plugged in a value for x. I never found a key point to find that instantaneous velocity. I kept it generalized. And I worked it out until I could see the general rule, the 2x plus 1. I found the 2x minus 1. That's the general rule for the slope of any point x on this curve, this function, 3x squared minus x minus 2. And that's what a derivative is. It describes every slope of every point. If it exists, that's really important. It may or may not exist. There may not be any slope at those different points. So that's where you're headed. And I want you to give this type of problem a try with your checkpoints. So you're going to try and find the derivative of the function, and then find the slope of the function at x equals 3 and at x equals negative 1. So use the formula that you saw at the beginning of this video. Question 2 is an application. So using what you know, you can use anything you want to use to help you find that. We've already done some problems like that. We're kind of reverting back to where we started when we talked about throwing things in the air and what's the speed at certain points in time. So see if you can describe the speed after 12 seconds. Bring these questions into class and we'll go over them. And don't forget to take the final survey question that was asked of you so I can get some feedback about how class was this year. It's called the End of Course Feedback, and it's on the Moodle page.